Welcome to the Planet of Maths channel. In this episode, we will talk about adding and subtracting rational expressions. And here we have the first such rational expression. To add fractions, we need a common denominator. In this first fraction, in the denominator, we have 5 and x. They are multiplied together here. And in the second denominator, we have 3 times x. There is also multiplication here. To have a common denominator, we need everything that was here to also be here. But in this first fraction at the bottom, we have 5 and x, so we are missing 3 from this denominator. So here we multiply by 3. But since I multiplied by 3 at the bottom, I also have to multiply by 3 at the top. So I add a 3 at the top and bottom. And in this fraction, I have 3 times x, so I'm missing the 5 here. Therefore, I also multiply by 5 at the bottom and also at the top. And in that first fraction on top, 4 times 3 is 12. Here I multiply. And at the bottom, I also multiply 5 and 3. 5 times 3 is 15, and I just rewrite x. On the second fraction line, on top, 2 times 5 is 10, and at the bottom, I multiply 3 by 5, I have 15, and I still have x written down. And at this point, I already have a common denominator. It is the same here and here. So I can now write all of this on one fraction line, 15 times x here without any changes. The denominator does not change, and on top, I add 12 plus 10. And from this, I get 22 over 15x. This is the result for my first example. In example B, I have this operation. I will first copy the fraction without changes. In the second fraction, that 5 does not change. And here at the bottom, I have 3x plus 9. So I can factor out a 3 here. I factor out the 3. Then, in the parentheses from this part, when I took out the 3, I have x left. I write down the plus sign, and from 9 I'm left with 3, because 9 is 3 times 3. I take away one 3, the other 3 stays here, and at this moment here, where there is addition in the numerator, it should be treated as if it were in parentheses. And if we look now at these denominators, in this denominator I have such a parenthesis, and in this denominator I have the same parenthesis, but I also have the number 3. This means that in this fraction I'm missing this 3 here, so I'll multiply this denominator by 3, but I also have to multiply the numerator by 3. Here I move 3 to the front to make it the same as in the second fraction. At the top, I write 3x, and from that, I must subtract this fraction. Here I change nothing. And now I have common denominators, exactly the same here and here, so I can write it all on one fraction bar, 3, and in parentheses, x plus 3 doesn't change here. And at the top, I write this 3x, copy this minus sign, and copy this 5. And that's the result for my example B. Example C looks like this. Here at the top, nothing changes for now. I can't do anything about it, but I can do something at the bottom because here I have a 2 and here an 8. So I can factor out a 2. In the parentheses, from this 2x, when I take the 2 out, I have x left. I write down the minus sign, and the 8 is 4 times 2. So if I took the 2 out, there must be 4 left here. That's how my denominator looks here. I write down the minus sign. I write down the second fraction. And now it's time to add these brackets here, because it will look better that way and also be easier to calculate. Looking at the bottom, in this denominator, I have a 2 and such a bracket, and here I only have such a bracket, so what am I missing? I'm missing this 2, so I add the 2 here, but I also have to add this 2 on top. I've just moved these 2's to the beginning because it will be easier for me to see. Now I can already see that I have a common denominator. I have the same in the denominator here and the same here, so I can write it all on one fraction line. This numerator here doesn't change at all. I have nothing to do here. I write down the minus sign and write down this numerator from above. There's no need to rush too much with these steps because haste leads to mistakes, especially with signs. Now that I've done this quite slowly, I can see that at the top I can multiply the 2 by this bracket. I rewrite the denominator without changes. I rewrite 5 minus x without any changes as well. Now here, there is a negative 2. I multiply it first by x. This results in negative 2x, and then I multiply the negative 2 by negative 3. So here I get a positive 6. The denominator I no longer change, and at the top I can calculate. 5 plus 6 gives me 11, and negative x and negative 2x together make negative 3x. And that is my result for example C. Another example, example D. I have two fractions, I made the fraction lines a bit longer because here we will write something on these fraction bars. Now we need to put parentheses where there was subtraction or addition. So here we put parentheses as well. We treat this as a single whole and see what to do to have a common denominator. Here on this fraction bar in the denominator, I have x minus 2. And here I have x plus 4. So nothing repeats here, I have to add then. Here on this fraction line, I have to add a whole bracket x plus 4. But since I'm adding it at the bottom, I also have to add it at the top. So I have this bracket added here. And here I lack this bracket x minus 2. I add it at the bottom and also at the top. At this point, I already have a common denominator. There are two identical brackets in this fraction and in this fraction, so I can combine it into a single fraction. The common denominator will be these two brackets in any order. The order here does not matter, and at the top will be what was here at the top. For now, I will rewrite it without multiplying. I will rewrite this minus sign and rewrite what I had here above, also for now without multiplying. The key is not to get confused with these signs. I keep the denominator unchanged, and at the top I multiply. 5 times x is 5x. 5 times 4 is positive 20. Negative 3 multiplied by x is negative 3x, and negative 3 multiplied by negative 2 gives me positive 6. I write the denominator again without changes, and in the numerator, I reduce x's. 5x minus 3x is 2x. Positive 20 and positive 6 is positive 26, and I have the result for example D. Now example E, again kind of longer fraction lines. I write the first fraction for now, 3 on top, x plus 5 on the bottom. But x plus 5 I put in parentheses. Here I also copy this numerator x plus 2, but in parentheses. And x minus 1 I put in parentheses. Where there are additions or subtractions, I enclose that in parentheses. Now I look at what is missing in this first fraction. Specifically, what is missing here in the denominator. I have such a bracket, so I am missing such a bracket. I add the bracket x minus 1, I wrote it below, so I have to write it above as well. On the second fraction line at the bottom, I have the bracket x minus 1, so I write the bracket x plus 5. I write it at the bottom and write it at the top. I already have a common denominator, which are these two parentheses in any order. Now I write down what I had on top. Here I had a 3, and the parenthesis x minus 1. I copy this sign and copy these two parentheses from here. Now multiplying. At the top I multiply 3 times x, which is 3x. Also multiply 3 times negative 1, which is minus 3. And here with this minus, we do it like this. This minus is tricky, and it's best to handle it by just rewriting it. And in parentheses, we will write everything that comes from multiplying these two parentheses. We multiply like this. First this x times this x, which equals x squared. Then we multiply x times positive 5, which is plus 5x. Next, we multiply positive 2 by x, which will be positive 2x. And then we multiply 2 by 5, which will be positive 10. And almost the last thing we need to do here is to remove this bracket by changing the signs. But first, 3x minus 3, that doesn't change. And here, from this bracket, I have to change all the signs. Everything was positive, so now everything will be negative. So it'll be minus x squared, minus 5x, minus 2x, and also minus 10. I write down the denominator, and here on top I simplify. First, I'll take x squared. There's only one negative x squared. Then I simplify x. Here I have 3x, minus 5x is minus 2x. And another minus 2x is a total of minus 4x. And then a negative 3, negative 10 makes negative 13. And to make it really elegant, we notice that there are minuses everywhere here. Thus, I can take out such a minus before the fraction line, and all these terms at the top will change their signs. It will be positive x squared, positive 4x, and positive 13. And this is the final result for example E. The formula for the difference of squares. This formula looks like this, or it can also be written in reverse order, like this. In this form, the formula works such that if we have two brackets, identical brackets, only differing in sign, then we can make it so that the first thing from the bracket, we raise it to the second power, meaning x squared. Then according to the formula, there's a minus, and then it should be b squared, which for us is this 5. Raised to the power of 2 gives us the result 25 from 5 squared. Just for practice, here I have two identical brackets, there's x and there's 9. Here it's plus, there it's minus, Here the order of pluses and minuses doesn't matter. First, I raise x to the power of 2. I give the minus sign and raise 9 to the power of 2. That's 81. This is how this formula works in this direction, and now how it can also work in the other direction. If we have something like x squared minus, for example, 16, we can do it this way if we notice that 16 is 4 squared. So we have this difference of squares. Here we have one square, the other square, and subtraction. So thanks to this formula, I can write it like this. In the first parenthesis, I write what was here, x minus 4, but without those squares, so x minus 4 in the first parenthesis, and in the second parenthesis the same, but with a plus, so x plus 4. Having such a difference of squares, I can change it into 2 parentheses. We'll practice this again in this example. Here we have x squared minus 4. This 4 is interesting because 4 is 2 squared, so we'll do the same again. Write down what's here but without squares, and in the first parenthesis, x minus 2. And in the second parenthesis, what was here but with a plus. That's how the formula for the difference of squares can work. The formula for the square of a sum, or also the formula for the square of a difference. These are formulas, and they work in 2 directions, just like here or just like here. Just like here, it works when we have a bracket. In this bracket, there is addition or subtraction, and we are to raise it to the power of 2. According to this first formula, we first need to square the first item from the parenthesis, which is x squared. Then you copy this sign, which is plus. And then it's called a doubled product, meaning we take the product of x and 4, what we have here in the parentheses. X times 4 is 4x, but it has to be a doubled product, so I double this 4x, resulting in 8x. And finally add b squared, which is add 4 squared, that will be 16. This 16 is 4 squared. Another example. I have a parenthesis inside the parenthesis subtraction, and all of these squared. So now, according to the second formula, it goes like this. X squared first, then that sign, and then there should be again that doubled product. So I calculate the product of x times 5, which is 5x, and I need to double these 5x, and I get 10x. I write it here, and finally there is a plus again. The 5 needs to be squared, which will be 25. This is how these formulas work in this direction, and now how the formulas work in the other direction. Here we have to notice perfect squares. If we have such a quadratic trinomial, here at the beginning we have a square, and here at the end we would also have a square. It would mean that we can use the formula here. And the number 25 is a perfect square. It is the square of the number 5. Instead of 25, we look at it as 5 squared. And now we have exactly what is in this formula. We have a squared at the beginning and b squared at the end. We'll check the middle in a moment. Then we do it like this. We put brackets here according to this formula. It should be a plus b here, which means what is at the beginning without the square, which is x, plus what is at the end without the square, which is 5. And all of this squared. That should be correct, but we're not sure yet. The beginning matches, the end certainly matches. We need to check this 10x for a moment, and we check this 10x like this. X times 5 is 5x. And according to this formula, we have here the doubled product, so if you double these 5x, it should give us 10x. And that's exactly how it comes out here, so everything matches. In this example, we notice that this 4 is 2 squared, so according to the second formula, it might be like this. We take x without the square, we take 2 without the square, and we take this sign from here, and we square all of this. It should match. We only need to check the middle, and the middle has to be the product of x times 2, which is 2x, and when you double this product, according to the formula, 2x doubled gives 4x, so everything matches here. Example F, I will reduce to a common denominator, so those longer fraction bars will be needed. For now, I have exactly the same as above, but now I do something like this. First, I have subtraction and addition here, so I enclose all of this in parentheses. And at the bottom, here I have such a parenthesis, so I'm missing that parenthesis for the common denominator. I add this parenthesis, x plus 2, but I added it to the bottom, so I add it on top as well. In the same way, here I have a parenthesis, x plus 2, so now I'm missing this parenthesis, x plus 3. I add x plus 3 at the bottom and on top. I have a common denominator, x plus 3, x plus 2, so now I can write everything on one fraction bar. For now, I'm not calculating anything, meaning the first numerator, x minus 2, x plus 2. I'm not changing. I rewrite the sign, which is minus, and write the next two brackets, x minus 3, x plus 3. The denominator remains unchanged, and here at the top, we see it's the formula for the difference of squares. If I have two identical brackets, x minus 2 and x plus 2 with only a difference in sign, then I use the formula. First, I square the x, put a minus sign, and square the 2. 2 squared is 4. That's what comes out of this. And here I have to be a bit more careful because there's a minus. So I write the minus, and in the parenthesis, I'll write what will come out from the next formula. Because here again, I have x minus 3 and x plus 3. So it is the formula for the difference of squares, which gives me x squared minus this 3 squared, which is 9. I write down x squared minus 4, and here I drop the parentheses and change the signs. It will be negative x squared and positive 9. I reduce what I can at the top, positive x squared, negative x squared, so that cancels out completely. I'm left with only negative 4 plus 9, so it results in a positive number 5, and that is the answer for my example F. In example G, I do not change this numerator. From this denominator, I replace 9 with 3 squared, and using special product formula, I got something like this. It means that in the denominator, I can write x plus 3 squared. And this is my first fraction. I rewrite the second fraction, I only add brackets, because this is addition. And now I look like this. X plus 3 squared is otherwise x plus 3 times x plus 3. That's how a square works. So here I actually have two identical brackets. And here, I only have one such bracket, so to have a common denominator, I need to add another such bracket, namely x plus 3. And having added it at the bottom, I also add it at the top. So I have a common denominator, which is x plus 3 squared, because I can write it like that too. And since there is a common denominator, now I can combine these numerators. Over one line, I put x plus 1, plus, and here I also place these two parentheses on the same fraction line. Nothing changes at the bottom. X minus 1 does not change. I write down the plus. And here I notice, because you could multiply each parenthesis by each other, but here it would be good to notice that this is the formula for the difference of squares. In the first bracket I have x minus 3, and here I have x plus 3. So from this, I get x raised to the power of 2, which is x squared, subtract, and I need to raise 3 to the power of 2, which will be 9. And since there was a plus here, I don't really need to put it in brackets. I could, but it's not necessary. And I reduce what I can. X squared first without reducing, x then without reducing. I reduce minus 1 and minus 9, resulting in minus 10, and I have the result for example G. Example H looks this way. We use what we did in previous example. Instead of 36, we put 6 squared, and we get x plus 6 squared here, and then we took it from this denominator, so I'm writing it down here at the bottom, x plus 6 squared. At the top, I write x. In this denominator, I can factor out x, and in parentheses, I left with x plus 6. On top, it's x minus 6. I will put this in parentheses because it's better to have that subtraction in parentheses. And now I look at the denominators. Such x plus 6 squared is otherwise x plus 6 times x plus 6. So here at the bottom, I have two such brackets, so what am I missing from this denominator? Here, I already have the bracket, but I don't have x, so I add x here, but if I added it at the bottom, I also add it at the top. And here I already have all done. And now on this fraction line, when I look, what did I have here? I already have this x. I have one bracket x plus 6. And here there are two brackets x plus 6. So I add one more bracket x plus 6. I add it on the bottom and on the top. The common denominator is already there. I then write everything on one fraction line. X plus 6 squared times x. And on top, I can multiply this x with that x. It will be x squared, and here I'll rewrite this. It's better not to rush here. I have x minus 6 times x plus 6. I will write this x at the front. It looks better. Then x plus 6 squared in parentheses. I write down x squared. I have a plus, so I don't need to use brackets, and I use the formula for the difference of squares. When there are two brackets that are identical except for the signs, it results in x squared first, then minus, and 6 also squared. 6 squared gives 36. Denominator unchanged, and on top, I just reduce. X squared plus x squared is 2x squared minus 36 copied. and I have the result for example h. And the last example. Here basically, there will be nothing new. It will still be an exercise in the formulas of special product, so I encourage you to do this example yourself by pausing the video and calculating it on your own. Extend the fraction line. On top, I write 5. At the bottom, I write x minus 4, I put it in parentheses. And on the second fraction line, I write x minus 4 in parentheses, and at the bottom, I factor it using special product formula, so I write this bracket instead. It's the same, x plus 4 squared. And now, to have a common denominator, what am I missing here? I'm missing these two parentheses here because x plus 4 squared are two such parentheses, so I add these two parentheses here, x plus 4 squared. And such x plus 4 squared I must also add at the top. I added it at the bottom, now I'm adding it at the top. What am I missing in this place? I am missing such a parenthesis, x minus 4. I added at the bottom and added at the top. I have a common denominator, so I write everything on one fraction line. I copy this from the top of the first fraction. And here I write it a bit differently, because here I have two identical brackets. Since I have two identical brackets, I can write that it is x minus 4, but squared. That is how my numerator looks. The denominator will not change until the end, and now I count the top like this. I have the special product formula, but I also have a 5 in front, so I need to keep that 5 and enter in the bracket what comes out from this special product formula, that is, from this formula. And this formula works such that x is first squared, so x squared. Then I copy this sign from here, do x times 4, which is 4x, and I have to double those 4x, that will be 8x, and also add 4 squared, which is 16. I have this from the special product formula, but I also have another special product formula. Here I don't need to put a bracket because there's no minus in front, there is no number here, so I calculate it right away, using this formula, which works like this. First x squared, so x squared. Then I copy this sign, which is minus. Next, I do the doubled product, which means first I multiply these two terms. X times 4 is 4x, but I double it, so that becomes 8x. And then you still need to add that 4 raised to the square, which is 16. At the top, I still have to eliminate this parenthesis, so multiply by 5. 5 times x squared is 5x squared. Then positive 5 times positive 8x is 40x. And 5 times 16 gives me 80, and I rewrite the rest. 5x squared and x squared are reduced. Together it is 6x squared. Positive 40x and negative 8x will be positive 32x. And then 80 plus 16 equals 96. And that's the end of the example. And that's all for this video. Thank you for watching, and I invite you to tune in for the next episodes on the Planet of Mass channel.